Welcome to the KF Physics Academy. Today we are going to the start of the statistical mechanics. What is the first question? The Fermi energy for free electrons gas at absolute zero is order of. This one is a very straightforward question. We know that this energy, free energy, is always in the form of electron volt. Electron volt means option number which one is correct? First one. The Fermi energy is measured at absolute zero in order of electron volt. Okay. Next. If the temperature of the black body is increased by a factor of 2, then amount of energy per volume radiated increased by factor. Okay, this one is a black body BBR problem. Okay, in BBR, energy is directly proportional to T to the power 4. Is directly proportional to T to the power 4. Okay, T to the power 4. Then here this is increased by how much? 2 times. Temperature is increased by 2 times, means this becomes 2T, bracket dash to 4, okay, means E is directly proportional 2 to the power 16 T to the power 4, 16 T to the power 4. Suppose we can show this one is even, this is E2, means E2 is increased by how much times? Then E1 is nothing but, means this is E2 is equal to 16 times of E1, 16 times of E1. Means this energy is increased by how much times? 16 times. So many times they ask this one. Suppose sometimes they ask what is the photon? How much number of photon is increased by this case? In this case, photon is directly proportional to T to the power 3. T to the power 3. Same problem. Suppose only they ask what is how much number of photon is emitted from this case. Then T is equal to T1 is equal to this one. Then T2 is equal to how much? T2 is directly proportional to 2T the power 3. Okay, means this T2 is equal to how much? 8 T cube. 8 T cube. T cube is nothing but P1, means P2 is equal to 8 times of P1. Got it? Means number of proton increased by 8 times of initial photons. Yes or no? When we increase the temperature is doubled. Nice question. For a system of n non-interacting fermions enclosed in a volume V at a constant temperature T, the average occupation number of the earth energy level is given by. Okay, we know that distribution function f of epsilon is equal to 1 upon e to the power alpha plus beta epsilon plus 1 for FD statistics. This is a distribution function for FD statistics. Okay. Next, B statistics 1 upon e to the power alpha plus beta epsilon minus 1. For this is B statistics or boson case. This is for fermion case. This is for boson case. Okay. And next for MB statistics, f of t is equal to 1 upon e to the power alpha plus beta epsilon. Okay. This is for MB statistics. Okay. Now here is alpha is only replaced by mu into F. Mu into beta, okay, minus mu b. And here they ask for earth energy level, hence write down f of b is equal to 1 upon e to the power alpha is equal to minus mu b, and we consider this one is a earth state energy, earth level energy. Then beta we can take common out, er minus mu, because alpha value is equal to how much? Minus mu b. Okay, means this is the occupation. This distribution function is known as occupation number. Okay, occupation number. Okay, and occupation number for FD or for fermions. This one. For boson case, occupation number is equal to this one. And this is for MB statistics. This is MB statistics. This is not for any case, for MBB or FD. Now our question, equation number n of r is equal to e to the power beta epsilon r minus mu, or sometimes we can take e to the power minus inside the bracket u minus epsilon r. Next problem. A gas at a molecule each of mass m is in a thermal equilibrium at absolute temperature T. If Vx, Vy and Vz are the temperature of velocity V of each molecule, then main square V is equal to how much? 2011 question. Okay. Now here, how to find out the Vx square? Suppose we can find out for 1D case. Vx square is equal to how much? 1 upon n. Okay. Vx square dx Vx square dx. Yes or no, general? Vx square dx. Okay. Now we can substitute this value in this equation. Then Vx square become, for 1D case, density of state, here minus infinity to plus infinity limit, 1 upon n minus infinity to plus infinity, n for 1D, m upon 2 pi kt, bracket s to 1 by 2, bracket s to 1 by 2 into e to the power minus mv square upon beta e. Yes or no? Beta e. Beta is equal to how much? 1 upon kt. And we know that here, what is the kinetic energy? 1/2 mv square. Okay. Means here write down the mv square upon 2. Why we can write down the here 2? Because we know that kinetic energy is equal to 1/2 mv square. Okay. Into dx. Sorry, here is a dvx. Here dvx. Got it? dvx. Now we can take common out in this case. This n get cancelled. This is the for 1D. Then this is equal to how much? Write down m upon 2 pi kt. Bracket s to 1 by 2. Okay. And here is a vx square. Okay. Acceptation. Limit minus infinity to plus infinity. Vx square e to the power minus mvx square upon 2 kt into dx. Into how much? Dx. Now here we can use the which formula? Gamma integral. But gamma integral must be limit must be 0 to infinity. But here function is a even function. Even function we can write on the 2 times of this one. Means 2 times m upon 2 pi kt. Bracket is to 1 by 2. Limit 0 to infinity. Vx square e to the power minus mvx square upon 2 kt into dvx. Okay. Now we can apply the which integral? Gamma integral. Gamma integral formula 0 to infinity x to the power m e to the power minus x to the power n dx is equal to 1 upon n gamma m plus 1 upon n divided by a to the power m plus 1 upon n. Okay. Now comparing this one, here m is equal to 2, n is equal to 2, and what is the value of a? Vx square remove out, and what is the remaining part? m upon 2 kt. Means m upon, comparing these two equation, we are getting a value is equal to m upon 2 kt. Now substitute this value. This is equal to how much? 2 times m upon 2 pi kt. Bracket is to 1 by 2. Okay. And here we are getting the gamma 1 by 2, gamma 3 by 2. Gamma 3 by 2 means root pi by 2. Gamma 3 by 2 means root pi by 2 upon a is equal to m upon 2 pi kt. m upon 2 kt. Okay. Bracket is to m plus 1 upon n, means this become 3 by 2. Okay. And now which part get cancelled? Here 1 2 get cancelled. Next m upon 2 pi kt. Bracket is to 1 by 2 into root pi by 2. We are going to in numerator 2m kt. 2 kt upon m. Bracket is to 3 by 2. Okay. Here root get cancelled. Okay. Next, this root 3 by 2. 2 to the power 3 by 2 can be written as 2 to the power 1 by 2 and 2. Okay. 1 by 2 and this 1 by 2 get cancelled. Okay. Here kt also you can write down kt into k to the power 1 by 2. When k to the power 1 by 2 get cancelled. Okay. Next. Here m also we can write down m to the power 1 by 2 into m. Okay. Means 1 by 2 get cancelled. Okay. And 1 m giving to the numerators. Okay. Yeah, sorry. M upon 2 pi kt. Bracket is 2. We can solve this one. We are getting how much? This is equal to kt upon acceptation vx square is equal to how much? kt upon m. Okay. Second one. second one kT upon m, we are getting kT upon m. Similarly for Vy also, Vy square kT upon m, Vz square also kT upon m. Okay, means what is the net? V square is nothing but Vx square plus Vy square plus Vz square. Got it? Vz square means what is this one? Kt by m, Kt upon m plus Kt upon m plus Kt upon m. And this is equal to how much? 3 Kt upon m. For which case? For 3 decays. This is for 3 decays. Suppose they ask for 2 decays, then 2 decays 2 Kt upon m. For 1 decay, simply Kt upon m. Okay. Next, what is the acceptation of Vx? Acceptation of Vx, how much? 0. Similarly, y, acceptation Vy, 0. Acceptation Vz, also 0. Acceptation Vx, Vy. Why this is equal to 0? Because here we can take the Vx, here limit is minus infinity to plus infinity, and Vx means the limit is even, function is odd. Limit even, function odd. This is equal to how much? 0. Okay. Even function, odd limit. Odd limit means minus infinity to plus infinity, 0. Or even limit, odd function, 0. Next problem. Again, this is of 2012 only, but here is a November paper. For motion of a two-dimensional face of the phase space required to represent the state of the particle must have at least how much dimension will take place here. Okay, this one is a mu pace concept. Here is a mu pace concept. Here we need to position and momentum. Generally, we can think that here is a 2 particles and 2 dimension. 2 particle, 2 dimension. Degree of freedom is simply 4. We can write down option number 3 is correct. Option number 3 is correct. But this system is not like that. 2 particle, 2 degree of freedom is 2 particle and 2 degree of freedom. Then total dimension is equal to 4. This is not like that. Okay. Here for first particle position x1, x2. For which particle? First particle. Okay. This one is the position degree of freedom. And second one, momentum P1 and P2 for first particle. Okay. Means this is equal to how much? Total is equal to how much? 4. This is equal to how much? 4. Yes. This is equal to how much? For first particle degree of freedom is 4. Degree of freedom is 4. For same for second particle 2 position coordinate x1, x2. Suppose you consider the prime and p1 prime, p2 prime. Okay, means here degree of freedom is how much? 4. Means here total dimension 4 plus 4, 8 dimension. Got it? 8 dimension. Suppose 3 particle and 3 degree of freedom. 3 particle and 3 degree of freedom. Then x1, x2, x3 for first particle. Same for x2, x1 prime, x2 prime, x3 prime. This is the position for second particle. Same for position for third particle. x1 prime, double prime, x2 double prime, x3 double prime. Means total position coordinate 3, 3, 3, 3, 6, 9. Okay. And the momentum P1, P2, P3. Next P1 prime, P2 prime, P3 prime. P1 double prime, P2 double prime, P3 double prime. Means total this is 9. 9 plus 9, 18 dimension. Yes, got it? 18 dimension for this case. Or sometimes they ask what is the volume for this case. Simply here formula dimension is equal to 2nf. How to memorize this one? Simply 2nf. 2nf. N means number of particles. F means degree of freedom. Here how much number of particles? 2 particles. Means here write down 2 into number of particles 2 into degree of freedom also they are given 2. Okay, degree of freedom also given 2. Means 2 into 2 4, 4 into 2 8. Got it? And suppose system is a 3D. System is a 3 particles and 3 degree of freedom. Then we can use the 3n formula. 3nf. We can use 3nf. Okay. Means at that time 3 into number of particles. Suppose 1 particle and degree of freedom is how much? Suppose 3. Degree of freedom is 2. Suppose 3 into 2. Or we can take the 2 particles 2 particles and degree of freedom is 3. 3 into 3, 9. 9 into 2, 18. What is this? Same answer. This is for mu pace case. Mu pace case formula 2NF for 2D case and 3NF for 3 degree of freedom. And what is the volume formula? V is equal to HNF. V is equal to HNF. HNF. For this case, here 2 particles and 2 degree of freedom means here is a V to the power volume is equal to H to the power and F. Means here 2 particles and 2 degree of freedom, then H to the power 4. H to the power 4. And suppose this is a system is a 3D case. At that time, volume V is equal to H to the power 3 NF. Okay, H to the power 3 NF. Substitute 3 N into F. H X, so okay, P N F. Okay, and here also NF, number of particles into degree of freedom e to the power this one. Next. Next question. Consider a particle of spin with angular momentum of each spin has a 2s plus 1 projection along a x quantization. The total number of microstates. Okay, microstates is the depends upon the system. Here system is a spin. Means microstate x plus up and plus down. Means we can take the 1 spin system, 2 spin system, any number. Okay, we can take the 1 number, 2 number, 3 number electrons. Okay, each and every time, so we getting the spin 1 by 2, half plus half and minus half. Means here basis is 2. We can take the n number of particles, the number of microstates. This one is a basis. Basis how much? Up spin and down spin. This one is a basis. And what is the relation between number of microstates? Omega is equal to basis raised to n. Basis raised to n. Okay. Basis raised to n. Here they are given basis 2s plus 1. 2s plus 1. 2s plus 1 is a basis. Okay. And for n particle, number of microstate is equal to basis raised to n. What is the basis? 2s plus 1. And here raised to n. Raised to n. Means for this case, which option is correct? 2 basis is equal to 2s plus 1 raised to n. Basis raised to n. This is the basis. 2s plus 1. We can take n number of particles. Then again we getting 2s plus 1 raised to n. Not multiply. Bracket raised to n. Suppose here is a ln. Then we can take the ln 2s plus 1. No problem. But here is no any ln are present in this case. Means here number of microstate basis raised to n. Here basis is how much? 2s plus 1 bracket raised to n. This option number which one is correct? Option number 2 is correct. Next question, 2011 again. The volume of perfect gas is doubled. The number of n atoms and energy being held at constant temperature T. Okay. The change in entropy will be Nk ln V, 2 Nk ln V, Nk ln 2, okay, and 1 by 2 Nk ln V. What is the formula entropy for in changing volume? S is equal to Nk ln V2 upon V1. Okay, here V changes to 2V. Yes or no? Means V2 is equal to how much? V2 is equal to how much? 2 times of V1. Okay, means V substitute V2 is equal to 2V1, then V1 get cancelled. Means S is equal to we getting Nk ln 2. Each option is correct. This one. Next, the mean energy of an ideal gas having the n monoatomic perfect gas at a temperature T will be. Now here temperature, we know that potential energy is equal to 0 for ideal gas. 0 for ideal gas means total energy is nothing but only kinetic energy, and kinetic energy is equal to yes px square upon 2m plus py square upon 2m plus pz square upon 2m. Yes or no? And acceptation of or Hamiltonian of this case is equal to how much? This one. Then acceptation of Hamiltonian is nothing but energy. Okay, and we can find out the acceptation of px square upon 2m plus acceptation of py square plus acceptation of pz square. Okay, here we can use the equipartition theorem. equipartition theorem. Equipartition theorem. Okay. What is the equipartition theorem? Each quadratic term contribution is 1/2 kT. Each quadratic term contribution is half kT. Half kT. Okay. Means this a px square upon 2m. This is a quadratic term. Means this contribution how much? Acceptation of h is equal to 1/2 kT. Second, again 1/2 kT. And third also 1/2 kT. Means any quadratic term contribution is equal to half kT. Half kT plus half kT plus half kT means this is equal to how much? E is equal to 3/2 kT. 3/2 kT for n particle. For n particle is equal to how much? E is equal to n into E1. N into E1 means this becomes 3/2 n kT. 3/2 n kT. Which option is correct? Okay. 3/2 n kT. And velocity kT upon m. Here 1/2 kT. Here we can use the equipartition theorem. Next question. This was a very lengthy question actually. Consider a system of a spore spin with S is equal to 1/2 and a magnetic moment mu. It is placed in an external magnetic field of H. The magnetic moment can be either parallel or antiparallel to the magnetic field. Consider a macro state. Consider a macro state or not a micro state of the system with energy is equal to how much? Minus 2 mu h, using the postulates of equal priority probability. The probability of finding the system with magnetic moment minus 2u. With the magnetic minus 2. Yes or no? Means here we can find out the probability. Now here, what is the probability for u? Here is a micro state, okay? For micro and macro. Micro probability. P 4u naught is equal to how much? 1 by total combination 16. Total combination 16. Then probability for micro state 1/16. Okay. Next 2u naught. Probability 1, 2, 3, 4 means 4 by 16. Probability for 0 4 by 16. Probability for minus 2u 4 by 16 and probability for minus 4u 1 by 16. But they ask for macro state, not a micro state. Macro state 1 by 16 for P 4u. Next P2u macro state 1 by 16. Next for P0 macro state 4 by 16. 1 by 16 barabar. 1 by 16. Next. Probability for this total number of macro states. Okay, macro state. This is for micro state. Probability for macro states. Okay, here is the total how many macro state? 1, 2, 3, 5. Okay. Then what is the now yes, what is the magnetic? They ask what is the magnetic moment. Finding the probability of the system. The probability of equal priority probability. The probability finding the system with the magnetic moment minus 2 mu is given by minus 2 mu. How many times we getting the minus 2 mu? 1, 2, 3, 4. Okay. Means for this case probability is how much? 4. Total number of microstates 16. 4 by 16 how much? 1 by 4. Which option is correct? Option number B is correct. 1 by 4. They ask for minus 2u. They are given the macrostate, no problem. But here finally they ask for what is the probability for minus 2 mu state.